Let's look at these examples. So this is examples that relate that need you to use the knowledge of properties of dot product. As you know that A dot B is the same as the magnitude of A, magnitude of B, cosine theta. From these three, the most important result will be A dot A will be magnitude of A square, right? The first result. So in the previous, I have discussed the properties of scalar product. So now I just a summary. So, and you have to know that if A dot B is the same as B dot A, right? And the third property will be if there are lots of properties relate to dot products. So, but I just stated these three because this three is needed by this question. All right. Then A dot B will be 0. Alright, so this is the very important properties. As A dot A is the magnitude of A square, A dot B is the B dot A. If A perpendicular to B, then A dot B will be 0. So, okay, let's look at this question as two non-zero vector. A and B is a non-zero vector. So, and if this and this are perpendicular, when they said this and this are perpendicular, show that then the result will be the magnitude of A and the magnitude of B will be the same, alright, will be the same. So how to show that? So of course I know that A plus B, right, are using the third properties because they already tell us that these two are perpendicular. So when these two are perpendicular, you are getting a 0 immediately. You're writing this, right? Why? Because they have stated that if these two is perpendicular, when they said that this is perpendicular, means that this vector dot with this vector, you are getting a 0, right? So then we expanding. So we try to prove that A dot A followed by negative A dot B followed by B dot A followed by negative B dot B is equals to 0, right? So magnitude of this, you were getting A dot A, you were using the properties one, which will be magnitude of A square, and negative A dot B plus with B dot A, negative A dot A plus with B dot, because you know that B dot A, second property, B dot A is the same as A dot B, right? So I can rewrite this to be negative A dot B plus with B dot A is actually A dot B, right? Minus with B dot B, which will be magnitude of B square equals to 0. So, and this one negative, one positive, they add up to be 0. So, and I can say that magnitude of A square is the same as the magnitude of negative, right? Negative with magnitude of B square is equals to 0, right? So, this shows that magnitude of A square is the same as magnitude of B square, right? Definitely, these two will be the same because why? Because you minus, you're getting 0, right? These two must be an identical number, right? It's a number. So if these two will be the same, the magnitude square, the value will be the same because magnitude always positive, right? Always positive. So then this one imply that magnitude of A is the same as the magnitude of B, right? So we have already shown this is true. This statement is actually true by using these three properties. So let's go for more examples about this type of using the properties of scalar product to prove another identity. Alright, this is also an identity where they tell if these two are perpendicular, then this will be the result. Right? Okay. See you for more example in the next video.